Will you go put the side link? That's fine. Put that side link. So I'm going to have some of you guys fill stuff in as we do this. Right, so Garrett's going to fill in the side link. Is that right, Garrett? 36, 16, 52, right? Didn't you get the square root of 52? So that's 4 times 13. Yeah, go ahead, fill one in if you want to. Yep. Maybe one person, maybe we could start to fill up the top. So maybe 6 different people could go fill up the top and maybe fill them in. Actually, Evan, why don't you fill in sine and cosine for me, right? Fill in sine and cosine for me. Okay, so then maybe another person, if you guys think you have the triangle for the bottom one, right? Cole, do you think you can build the triangle for the bottom one? So on Cole's, does it matter where angle A is? Right, because it does matter where angle A is. So we do need angle A, but I think he's okay on his sides. So maybe everyone in the middle set, so that's the 6 of you guys. If you guys could go put up one trig function, please, whenever you have it. Doesn't matter if it's on the top or the bottom. And then so Hayden, if you can fill in 2 for me. 2, fill in 2 of them. I know, so much work. So yesterday when we started these problems, guys, right? We started with the rules. We filled in all 6. We looked at reciprocal identities. Then we filled in 3. We looked at reciprocal and quotient. We filled in 2, right? So that's why I had Evan fill in those top 2 on the top one. So all the other ones should go off of sine and cosine. What does cotangent say, guys? Does that say 8 over 3, 2 over 3? What does cotangent say up there? Who put cotangent up? I just can't read it. It looks like an 8. It looks like a 2. 2 over 3, right? So cotangent up there is 2 over 3. You didn't know how to use a pencil? 2 over 3, right? All right, are you guys good with both of the triangles? Are those okay? Right, nice and easy, a squared, b squared, c squared. So when I don't give you a triangle, right, you're going to build it off the function, so adjacent over hypotenuse. If you want, on all of these problems, if you notice that the sides have something in common, if you want to, you can reduce the sides off of the triangle, so then you don't need to simplify every single one, right? So if you reduce it off of the triangle, then simplifying will be a little easier, right? So rad 7 over 4, 3 over 4 is given. So then rad 7 over 3, flip it and rationalize, flip it and rationalize. So these were given off of the triangle, right? So if sine, we had 6 over 2 rad 3. You probably want to write that first. So then when you do a reciprocal, it's nice and easy. Any questions on all of those? So we are going to use your calculator a little bit today. We're going to use 30, 60, 90 a little bit today, right? So that is where I'm starting, okay? So we are going to do a bunch of these problems that all involve 30, 60, 90. Now, usually when you do a set of problems, you would do this is going to be non-calculator. So our second thing we're going to do is going to be calculator, right? So anything that's ever 30, 60, 90, 45, 45, 90 is always going to be no calculator. I want you to get in the habit, though, of not doing these set up like this. I don't want you to do number 1, number 2, number 3, number 4, number 5, number 6, and then the second row. I want you to look at them as a group of 12 problems in the easiest way to do them. So which way do you think would be easier to do? Do you think it would be easier to do all the ones that involve sine together, all the ones that involve cosine together, all the ones that involve tangent together? So do you think you should organize it by trig function, or do you think you should organize it by angle? Do all the ones that are 30 degrees together? Do all the ones that are 45 degrees together? Which way do you think is more efficient to solve them? Trig function or angle? What do you think? Joshua? Right? Angle over trig function. So that's how I want you to look at it, right? So let's build our 45, 45, 90 first, okay? And we're going to build it in a way that in both cases, I want the hypotenuse to be 1, right? Because I'm trying to prep you into the next section. So I don't want to give the side lengths as 1 and the hypotenuse as a rad 2 idea. I want to give the hypotenuse as a 1. Go solve both legs. All right, what will both of those legs equal on a 45, 45, 90 triangle? We know both of the legs are the same, so I could label them both A. I could label them both B. I could label them both X, right? I'll label them both X to get us started. Rocco, what equation can I use to solve for X now? Agree. So set it up. What is it going to look like for us? Equals 1 squared, which is 1, right? So then I'm going to go 2x squared when I add them together. I'm going to divide by 2. Bailey, how do I square root both sides on that? What am I going to get? X equals what? Which is? Not 1/4. What's the square root of 1? What's the square root of 2? Good. So it's going to be rad 2 over 2. Right? So X is going to be rad 2 over 2. So maybe you're saying, well, that looks more complicated, right, than the way that we would normally do it. But there is a reason, right? There is a reason. So that's our 45, 45, 90. Is everybody okay on how we solve that? Right? Is that okay? All right. So now pick out all the ones that are 45 degrees. So do those 4 only. Believe me that this is the easiest way to do these problems. Eventually, you're going to have a list of like 30 of these, and I'm going to give you like 10 minutes to do it. Right? So believe, not even 10 minutes probably, right? Yeah, 10 minutes would be way too long. 30, maybe like 4 minutes, right? Eventually, we'll get there, right? But believe me that doing all the ones that relate to the same angle are the easiest way. 4 people by the whiteboard, if you guys could go put up those answers when you get them, right? So 4 people by the whiteboard, go put those up. No decimals, no decimals, no decimals. Right? We're not using calculators, guys. We're just using that triangle. You turn the pen around and use the eraser. Yep. No decimals, just triangle. Right? Just triangle. All right, so we got 2 of them, 2 more people over there. I need cosine and then I need cotangent. Cosine, cotangent, 2 people by the whiteboard. Come on. Which one should be so easy that I have sine and cosecant there? Which one should also be incredibly easy that I have sine and cosecant there? Which one's exactly like one of the other ones? Cosine or cotangent? Cosine or cotangent is either rad 2 over 2 or rad 2. Cosine or cotangent? Come on, what's true in a 45, 45, 90 triangle? Which 2 sides are equal? Opposite and adjacent? Aren't they equal in a 45, 45, 90? Not one. Right? You guys are killing me here. Right? Isn't sine and cosine? Isn't sine and cosine exactly the same? Opposite over hypotenuse. Adjacent over hypotenuse. Aren't the legs the same in a 45, 45, 90? Yes, right? So wouldn't sine and cosine be equal? Right? Sine and cosine would be equal. So rad 2 over 2, rad 2 over 2. We already had this one done, rad 2 over 2. So now what's cotangent of 45? Cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, so it is 1. So why did I have you do the triangle in this manner? I'm just going to write the answers a little neater because I want them to stand out, right? So why did I have you write the triangle like that if those are the 4 answers? Joshua? For which trig function? Wouldn't that also happen if, right? Wouldn't that also happen if I just called this x and x? Or if I called the legs 1 and 1? Wouldn't it still cancel? I think that's what you're saying because you chose tangent. Okay. What I'm trying to have you see, when you name the triangle like this, and you do sine over and cosine, why is having the hypotenuse 1 nice? It's just the numerator, right? So it is just a side length, right? My answers are just a side length, right? So that's what I'm trying to have you look at, right? My hypotenuse is 1, So when I do sine and cosine, because those are the only two really important ones, right? Because if I can get sine and cosine, I can get the rest of them. The denominator's 1. So it's just the side length. Okay? All right, those are all the 45, 45, 90 ones. So now let's build the 30, 60, 91. So 30, 60, 90. I want to do the same thing. I want to make that hypotenuse 1. So find the other side lengths. Find the other side lengths. So short in relation to hypotenuse. Leo, if the hypotenuse is 1, how much is the short? A half, right? So short is opposite the 30, right? Short's opposite the 30. If the short is a half, Faith, how much is the long? Short times what is the long? Times rad 3. So then the long is rad 3 over 2. Okay, we okay for those side lengths? All right, so we're going to do the 30 ones now. 30. So Peyton, I did a little blue in the 30, but I didn't want to give it away. Pi over 6 or pi over 3? Which one's 30? Pi over 6. So those are the those are the 4 that I want you to do right now. Those are the 4 I want you to do. I want you to do 30 degrees or pi over 6 radians. So do those 3, 4, please. Sorry, do those 4. Can you understand why doing it by the angle is easier, right? You're concentrating on one angle and you're just using opposite, adjacent, and hypotenuse to solve them. You're not kind of changing all of them as you go. You're concentrating on one angle and the sides are stagnant, opposite, adjacent, hypotenuse. Window people, you guys are going to do these 4. I've got 4 up there. So people by the window, once you have an answer, if you could put it up, please. And put them rationalized, right? You don't need to show your rationalization. Put the rationalized work. All right, we got 2 more, guys. We got tangent and cotangent. If you do tangent, then all you're going to do is flip it over to get cotangent. All right, so whoever by the window didn't go up, we got 2 more. So what did you guys put? You guys put cotangent is rad 3. Cecilius, what'd you get? Okay, well, look it up here. Look it up here now, right? Cotangent is rad 3. So what do we got to do to cotangent to get tangent? Just flip it. Flip it and rationalize. Right? So you can use your other answers to help you get the other ones. Okay? All right, we got 60 left. I don't need to do another triangle, right? So 1 person from each section, 1 person from the whiteboard, 1 person from the window, 1 person from the, maybe 2 people from the middle. Go put up those answers. So 1 on the window, 1 on the whiteboard, 2 in the middle. Go put up remaining answers. All right, we got 2 more. We got cosine and secant. They actually left easy ones, right? Because if you do cosine, then someone can just flip it to get secant. Actually, those two are pretty easy. Evan, will you just flip it? Thank you. All right, so what do you think? Are those easy? Are those good? So that's how I want you to do them. I want you to do them by the angle when we're using triangles. So no matter what order I give you, you look at all of them. You pick out all your 45s, you do them together. You pick out all your 30s, you do them together. You pick out all your 60s, you do them together. Right? There are going to be a ton of these problems, right? We got 6 trig functions, and we ultimately will have 16 angles, right? So 6 times 16, that's 96 problems that I could give you, and they'd all be different problems. But then I could also give you revolutions, right? And they'd be more different problems. So there's 96 base problems. So if you think you'd have to know 96 base problems, you're never going to be able to memorize that. You have to understand the easiest way to do it. Okay? All right, now let's use your calculator. Okay? So these ones are in your calculator. So let's first make sure you're in your calculator, and let's make sure you are in degree mode, right? Grab your calculator, put it in degree mode. Right? Put it in degree mode. So just like the last set, you are going to have a bunch of problems that are in degrees, that are in radians, and that are all mixed around, right? So mode, I'm making sure I'm in degree mode. Okay, so I'm going to try to get both of them in here at the same time so that we can use them together. So same deal. We're going to remember that my calculator right now is in degree mode. Degree mode. So which problems am I going to answer first? All right, calculator's in degree mode. Calvin, which one do you want to go for? Do you want me to start number 1, 2, 3, 4, 5, 6? No. No, because I'm in degree mode, right? I'm in degree mode. Is that degrees? Is that degrees? Is that degrees? Why is that not degrees? It's a decimal. I don't have a degree or degree minute symbol, right? So if your calculator is in degrees, we should be doing those two first, right? All right, but those two are a little harder. Do I have a cosecant button? Do I have a cotangent button? No, some calculators do, but the majority of the ones that you guys have don't. Garrett, what do you think you have to do? Tangent or sine, very good. So give me the name of the identity that you're using. Reciprocal identities, right? So I have an identity that says my cosecant of the angle is equivalent to 1 divided by the sine of that angle, right? So I could go use my degrees and my minutes. I'm so lazy though. I don't like going second, angle menu. How many decimals is 15 minutes? How many decimals is 15 minutes? 15 out of 60? A quarter, 0.25, right? So I'm lazy. I don't want to go do that. I'm going to go 1 divided by sine of 175.25, right? So I'm going to go over here, and I know I'm in degree mode. 1 divided by sine of 175.25. If I know I'm in degree mode, then I don't need a degree symbol, right? Hit enter, and there's your answer. So what am I getting? 12.076. Okay, 12.076. All right, let's think if that makes sense. All right. All right, so when I do sine, it's opposite over hypotenuse. Hayden, which one's always bigger? Opposite or hypotenuse? Hypotenuse is always bigger, right? So I have small over large. So now when I'm doing cosecant, I've got large over small. Does it make sense that my answer is over 1? Large over small, right? So you want to think of those things too. All right, you guys go try to do cotangent of 32. It's the same deal. I don't have a cotangent button. So I got to figure out some way to do it without a cotangent button. Leo, what's cotangent's reciprocal? Tangent, so what am I putting in the calculator? Very good, 1 over the tangent of 32. So 1 divided by tangent of 32. All right, before I hit enter, you might have already hit enter. Should it be over 1, less than 1? Do I not know? Right, so think about it. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. Are we guaranteed that one of those is bigger than the other? Opposite and adjacent, 2 legs. We're not guaranteed, right? So that answer can be anything. So I'm trying to lead you to like domain and range on these two, right? So I'm getting 1.600. Okay, make sure you guys are doing it in calculator and you're getting the same. Okay. All right, are those okay? All right, Mia, which one should we do next? Sine, we can do sine. What do we have to do in our calculator? Change the mode. So the other 4 are all radians. So I gotta change my mode to radians. Go do those 3, because I don't think I gotta tell you, hit the button, hit the angle. Right? Hit the button, hit the angle. Make sure your answer makes sense. So sine is opposite over hypotenuse. Hypotenuse is always my big one. So is the answer that I'm getting making sense? Do you guys agree with my answers? Are those okay? Does it make sense that sine and cosine are lower than 1? Why, Joshua? Good, I'm dividing by the hypotenuse, which is always bigger. So tangent is involved in opposite and adjacent. Those don't have any rules, right? So that can be anything. So is everybody okay with those 3 answers? All right, let's think of secant of pi over 8 first. Where should my answer fall? Should it be less than 1? More than 1? Secant. Hypotenuse over adjacent. More than 1 or less than 1? More than 1, right? So go and do secant. Go and do secant. What am I going to put in for secant? Not 1 over sine, 1 over cosine. 1 over cosine of pi over 8. Whoops. 1 over cosine of pi over 8, 1.024. Remember, 3 decimals. Okay, is that nice and easy? Right, so whether you're in degree, whether you're in radian, right, this is the harder side where you got to make sure you're using your reciprocal function. Okay, now let's go backwards. Right, oops, wrong one. Let's go backwards now. Right, so we're back to no calculator now, no calculator. Right, whenever you see some rad 2s, rad 3s, 45, 45, 90, those are going to all be no calculator. So you can see a whole bunch of the symbols that I used, right? So I used theta, gamma, phi, beta, alpha. So what am I asking in this one? Garrett saying, what's the angle? Very good. So what's the angle? All right. And again, we haven't been doing this for a long time yet, but I would think 1 out of these 6 should jump out and you automatically know the answer. Yeah. Okay, so Why is the tan 45 in that one? Okay, good. So I wasn't going to pick that one originally. I was going to pick the other one that's 45. What other one is 45? Dave, which other one's 45? My cosine. Because I got a rad 2 involved, right? So I don't know if you remember in geometry, but I always tell my geometry kids, right? You remember rad 2 involves 45 degrees because it's only got two angles, 90 degrees and 45 degrees, right? So that's the rad 2 one. And then you remember rad 3 is the 30, 60, 90 because there's three different angles, right? So you're good for the tangent one. I didn't know if anybody would pick up on that one. So that one's 45. This one's 45. Again, we're not even really looking at a triangle when we're doing that. Okay. All right. So now I'm going to build my 30, 60, 90 triangle. All right. So that was 30. I wanted the hypotenuse to be 1, a half, rad 3 over 2. So Mia, pick 30 or 60. 30. Okay. So I want to look at all of these 4 problems together. And I want you to think of what sine and cosine is. So if I'm at 30, is the sine of 30 rad 3 over 2? Is the sine of 30 rad 3 over 2? It's not, right? So then the answer has to be 60, right? So if you pick an angle and you say, okay, I'm going to find all the functions for that angle, if it's not 30, then it's got to be 60. Does that make sense? Right? So it's like process of elimination. So, okay, that one's good. All right. So now I'm going to go to cosine, right? Sine and cosine. Actually, no, I'll go to cosecant, right? So we just set up here that the sine of 30 was not rad 3 over 2, so it had to be a half. So is cosecant's answer 30? Is cosecant's answer 30? It is, right? They're reciprocal functions. So I did sine of 30, so that is 30. All right, so now I'm going to go cosine. Cosine of 30. Peyton, what is cosine of 30? Nope, cosine, adjacent. So ca. Not 3/2. Rad 3 over 2. So cosine is 30. So is this answer 30? Is the reciprocal of that here? No, so it's got to be 60, right? So now I've got these 2 items. Is the answer 30 or 60? Cotangent. Which quotient is cotangent? Is it sine over cosine or cosine over sine? Cosine over sine. So if I do cosine over sine, am I getting rad 3 over 3? If I do cosine over sine. Andrew, am I getting rad 3 over 3? Nope. Cotangent, right? If I'm doing cotangent of 30, I'm getting rad 3 over 2 over a half. The 2 2's would go, right? So I'm only getting rad 3. So if the answer's not 30, it's got to be 60, right? So see how I only really looked at one angle? And if it didn't work for that angle, it had to be the other one. You don't have to do it that way, right? But it's better than kind of looking at every single problem, looking at your triangle and trying to find it. Yeah. Sure. Yeah, that'd be fine. But do you know the decimal for rad 3 over 3? Okay, that's fine. All right. All right, now let's go to your calculator. All right, now let's, ooh, that's not your calculator. I did not write a calculator one. All righty, let me write a calculator one. All right, sine of theta is 1.92. Cosine of theta is 0.67. Secant of theta is 1.95. and cotangent of theta is 0.625. Okay, so top two, right? Top two are the easier two since I have the button, right? Top two are the easier two since I have the button. So when we are solving for the angle, I'm going to do the cosine one first. When I'm solving for the angle, that's when we're using the inverse function, right? I'm not saying reciprocal function. I'm saying inverse function. So do the cosine one. Second cosine of 0.67. Do the cosine one first. There is a reason. Oh, you know what we got to do just to have it better in your head? Change back to degree. Change back to degree just so it's better in your head. So second cosine of 0.67. Did you guys get 47.933? Degrees, right? You got to put degrees. 47.933 degrees. Go do sine. Right? So the cosine one was 47.933. Go do the sine one. What is it? Why is it an error? Very good. Sine, opposite over hypotenuse, small over large, right? Doesn't it have to be less than 1? I gave you something more than 1. I am going to give you things like that, and you have to understand that the calculator is giving me the right answer. It's saying that can't happen, right? I can't have sine being bigger than 1. So you would put not possible. Right? Not possible. I should have done that as of a second problem, right? All right. Here's the hardest ones, the bottom two. Okay, so secant of theta equals 1.95. I don't have my secant button. Leo, what's secant's reciprocal? Cosine. So if secant is 1.95, what is cosine going to equal? If secant is 1.95, what's cosine going to be? 1 over 1.95. So I'm going to tell you, these ones, cotangent, secant, cosecant, these are the ones that people get wrong. So you got to pay attention, right? Reciprocal function, reciprocal. So in my calculator, I have to do inverse cosine of 1 over 1.95. So inverse cosine of 1 divided by 1.95. 59.148. Is that okay? You guys try the cotangent one. Try the cotangent one. We are ultimately going to have like all of these kind of all mixed up. I call these ones backward ones. The other ones that we did, I call forward ones. So what are we going to do? We're going to do second tan of 1 divided by 0.625, 57.995. Is that good? Right? All right, since we're on our calculator, let's kind of show you something on your calculator. All right. Hayden, pick any acute angle. 24 degrees. Spectacular. 24 degrees. What angle is going to happen if I say negative 24 degrees? What angle is this one? Positive version. What angle is that one? 336? All right, so let's use these two angles. Let's use 24 and 336. Make sure you're in degree mode. Hit sine of 24 and then sine of 336. How do they differ? Opposites, right? Do cosine. 24 cosine 336. Same this time, right? Do tangent. Same or opposite? Opposite. Do secant. Secant's 1 over cosine. Same or opposite? Same on this one, right? All right, so cosine was the same, secant was the same, sine was opposite. What do you think cosecant will be? If sine is opposite, what do you think cosecant's going to be? Opposite, because they're reciprocals, right? And then if tangent is opposite, cotangent would also be opposite. So 336 is weird, though. Can I have 336 degrees in a triangle? So that's weird, right? But I'm still doing sine, cosine, and tan of it, right? So that's what's kind of bringing us into the next section. Okay, last problem. Angle of elevation, angle of depression, because that is going to use your calculator, right? So I think this one was the exact one on the prior knowledge. So let's try that one. Prior knowledge was the guy wire one. So let's try this one, ladder. It's all about drawing the picture, picking the right trig function, and using your calculator. Is my picture okay? Put the variable where you want to solve, right? So I put L for the ladder, and that's what I want to solve. So Peyton, what do I want? Sine, cosine, or tangent? I'm going to do cosine. Could I pick sine if I do something different? Good. Good word, right? If I find the complement, then I could use sine. So what are we going to do? The ladder's going to be 8 divided by cosine of 65, right? 8 divided by cosine of 65. Make sure you're in the correct degree mode. You get 18.930, right? 18.930. All right, is that good? All right, so how are these first two trig sections? Pretty easy? How many important things do you need to know? What type and how many? So what's the first thing you should know? The first thing you should know. First thing that should be in your head. Degrees and radians. Pi over 6, pi over 3, pi over 4, pi over 2. Right? So those are 4 items. What's the first name of the identities that you should know? First name of the identities that you should know. And how many do we have? 6. Not inverse identities, reciprocal identities. So 4 plus 6, 10 items, right? And then what? 2 quotient identities. So that gets us up to 12. And then do we really need to know 6 rules like SOHCAHTOA? Do I need to know all 6 of them? I only need to know 2 of them, sine and cosine, right? Because sine and cosine with all the identities, you know the other ones, okay? So all of that stuff should be on your important sheet, okay? Your important sheet. All right, so we are good. You guys are good for 4-2 homework. Some of you guys already did it. I'll tell you what, is it 66? That's the weird one, right? 66. Try 66.